In this video tutorial, I am going to discuss about some terminology related with the enzyme. We know that chemically almost all enzymes are protein in nature. So for that, suppose this globe represents enzyme. Now, in case of many protein, what happens? This entire molecule of enzyme is made up of purely protein. But in case of some enzyme, this entire molecule of enzyme is not made up of only protein. However, larger part is made up of protein, but very small fragment, let's say this much small fragment, it is made up of non-protein part. Whereas this larger fragment, it is of course made up of protein. So we can say that many enzymes are not made up of only protein, rather protein plus non-protein part. So in such case, this larger protein part, it is called as a apoenzyme, right? And this apoenzyme, when combined with the non-protein part, such enzymes are called as a holoenzyme. This complete assembly will be called as a holoenzyme. Now, let's focus on this non-protein part. This non-protein part, depending on their chemical nature, they are divided into two parts. If this non-protein part, it can be a metal ions, or it can be small organic molecule. If it is made up of metal ion, for example, it can be made up of magnesium ion, iron, zinc, or any other metal ion, then this non-protein part is called as a cofactor. Cofactor. Whereas if it is made up of small organic molecule, we call them as a coenzyme. So the difference between cofactor and coenzyme must be clear to you. Now this coenzyme, depending on their interaction with this protein part, how they interact with this protein part, there are further divided it into two parts. The first part is that if there is only a transient association, or we can say transiently associated with apoenzyme, then they are called as a co-substrate. Co-substrate. And if that association is of the permanent kind, so if they are permanently associated with apoenzyme, then they are called as a prosthetic group. So once again, coenzyme, depending on their association with the apoenzyme, they can be called as a co-substrate or prosthetic group. We can call them as a co-substrate if they are only temporarily or transiently associated with apoenzyme. And if they are permanently associated with apoenzyme, we call them as a prosthetic group. Right? Now, let us look at the examples. Now, in case of co-substrate, see, one very good example is of alcohol dehydrogenase. This alcohol dehydrogenase, it is made up of two parts. One is the apoenzyme part, and its co-substrate is the NAD+. So this association, it made up gives rise to complete holoenzyme assembly of the alcohol dehydrogenase. Now what this alcohol dehydrogenase does, it converts ethanol, it catalyzes ethanol to the acetaldehyde. Now during this reaction, what happens? This NAD plus molecule is getting converted to NADH plus H plus, and as soon as NAD plus is getting converted to NADH and H plus, it leaves. It leaves from where? It leaves from this enzyme assembly or this holoenzyme assembly. So the remaining portion will be only apoenzyme. So now you can understand that this NAD plus, it is only transiently associated with the apoenzyme. But once again, we know the rule of enzyme. that enzymes, they never participate. They participate in the reaction, but they are never change in the structure of enzyme. But here what is happening? Here the structure of enzyme is getting changed. So how this change in the structure of this enzyme is reverse. So what happens, as soon as NAD plus leaves as a NADH and H plus, the new molecule of NAD plus comes in and it associates with this apoenzyme part. So this thing we have to keep in mind. And because of this reason, it seems that NAD plus is not acting as an enzyme, not acting as a part of enzyme, rather it is acting as a substrate, right? Why substrate? Because see, NAD plus is getting converted to NADH plus H plus, and that is the reason it is called as a co-substrate, right? Now let us look at this prosthetic group. Prosthetic groups are permanently associated with the enzyme. And one very good example of this prosthetic group containing enzyme is the PDH complex, that is pyruvate dehydrogenase complex. Now in this PDH complex enzyme, FAD act as a prosthetic group. That means this PDH complex, it is made up of apoenzyme and permanently bound FAD. Now, what kind of reaction is catalyzed by the PDH complex? So, PDH complex basically mainly converts pyruvate to acetyl coenzyme A. And during this reaction, one molecule of coenzyme A is consumed and carbon dioxide is released, and simultaneously NAD plus gets converted to NADH plus H plus. Now see what happens. In this case, suppose this is the entire PDH complex and this part is the FAD. Now what happens? During midway of this reaction, this FAD, it gets converted to FADH2. So now it looks similar to this co-substrate type, but this FADH2 is not leaving the enzyme. Rather, what happens? As soon as FADH2 is formed, immediately it is converted back to the FAD with the help of this NAD. So simultaneously, this NAD plus, it converted back to this NADH to the NADH plus H plus, right? So at the end of this reaction, FAD is regenerated and it had never left this holoenzyme complex, right? So here we can say FAD is permanently associated with this PDH complex enzyme, and that's why it is a prosthetic group. Whereas here NAD plus, it is transiently associated with this PDH complex. So here this enzyme PDH complex has two things. This FAD is the prosthetic group, whereas this NAD plus, it is a co-substrate, right? So here we had learned about what is apoenzyme, then what is holoenzyme, then what is cofactor, what is coenzyme, then what is co-substrate, and what is prosthetic group. I hope that now onwards there will be no any confusion between this terminology. If you still have any query or confusion, please write it down in the comment section below. Thank you.